Well, we're going to discuss Mat181 trig, section 8.3, product and quotient theorems. So these are two separate theorems, the product theorem and the quotient theorem. So it's kind of an interesting little thing here. So what they did is they took a problem. They took this problem in your book. You can kind of see it, and we won't go through it in a huge amount of detail. But what they did is they took 1 plus I radical 3 times negative 2 radical 3 plus 2I. These two complex numbers, and they multiplied them together doing a FOIL, and then they combined the like terms and all that stuff. And finally, they came up with a solution. Then they decided, well, let's put those into polar form. Right now, they're in that rectangular form, and this would be the solution in rectangular form. And we're kind of familiar with doing a FOIL and handling I squares and all that kind of stuff. But we had done that back in 8.1. But we want to look at this now in polar form. So what I did is I took the two problems. I took 1 plus I radical 3, and x would be 1 and y would be radical 3. And I calculated the r, and it came out to be 2. And I calculated the angle using the tangent of theta equals y over x, and calculated that out, and it came out to the radical 3, and I looked that up, and this would be in the first quadrant, so that came out to be 60. So I had 2 CIS cosine 60 plus I sine 60. And I did the same thing with negative 2 radical 3 plus 2I, and I wrote that all out. And I calculated out the radius was 4, and the angle right here in between was 150. So if you want to pause this and look this over, it's fine. But if not, and then right here I rationalized it to make it a little bit faster. And I realized this was in the second quadrant. So, theta ended up 150. So that's basically what they said right here. That's how they got these values. They went through the same thing I did. And they wrote them out kind of in expanded form. Instead of writing out 2 CIS 60, they expanded it out. And then what they did is they decided to multiply these together, and it became a long process. I don't want to go through all this, but they multiplied the 2 cosine 60 times the 4 cosine and all this kind of stuff. And this is their manipulation of it. And finally, when they got through, they got it down to this point. So let's look at something kind of interesting here. Okay, so they were taking 2 CIS 60 times 4 CIS 150. Basically, that's what they're doing, right? 150 degrees, 60 degrees. And that's what they multiplied all out here. They had it expanded out a little bit, Right here, they're writing the whole thing out. But look at the answer they got when they got through. Can you see any relationship to this answer right here? Well, first of all, we got this 8. 2 times 4 is 8. And then they got cosine 210, I sine 110. Well, that would be CIS 210, right? So what is 60 plus 150? 210 degrees. So is there a faster way than doing all of that, which is a lot of work? Well, let's take a look. On the next page, they have developed some stuff. And by the way, they also took this and converted this back to polar coordinates. I'm not going to go through all that. But when they converted it back to polar coordinates, they got to rectangular coordinates. Did I say polar? When they converted this polar form to rectangular form, they ended up with exactly the same thing they had started out with. So So it's really the same thing. They could have just taken this answer and converted it over to this right here. But instead of doing that, uh, we have a simple way of doing it too. If it is in polar form, let's take a look and see how we could actually do that. Well, on the next page, they kind of show if you have some radius times CIS theta, we call it theta 1, times a different radius times CIS and a different degree here, theta 2, it's equal to R sub 1 times R sub 2, R sub 1 times R sub 2, 8, CIS theta 1 plus theta 2. And that's exactly what they did. They added these together. So this is a quick way, instead of going through all this work, to get the answer. So let's try one here. Let's move some of this out of the way, and let's try this example 1. So I want to multiply 3 cosine 45 degrees plus I sine 45 degrees times, and let's see if I can even fit it on the page, times 2 cosine 135 degrees plus I sine 135. Okay, so what I'm going to do is write it in complex. This is expanded form. Let's push it together. This is 3 CIS 45 times 2, let's just put it in parentheses, times 2 CIS 135. So how would we do that? Well, we could do, go crazy, but we could just multiply 3 times 2 is 6, multiply these two, and then add the angles. CIS 45 plus 135, what is that, 180? So we could write this as 6 cosine 180, 6 times this whole thing, plus I sine 180. Well, we could go back a little bit further than that. We can look up what is the cosine. We could leave it like that. What is the cosine of 180? Well, it's -1. And what's the sine of 180? You look at your chart, it's 0. So 0 times anything is 0. So now we have 6 times -1. So our answer to this problem is -6. So the product of these two things, if we translate it back to rectangular form, is -6. And if we wanted to write it as what do you call it, complex number, it would be -6 plus 0i. You get a little fancy if you want to. Okay. Well, in the next example, they went ahead and they took a complex number and they divided it. And to divide it, remember, you have to rationalize it. And that's what they did over here. So they took the complex number and then they rationalized it by multiplying by the opposite. This would still be -2, radical 3, but instead of plus, this is a minus. And they multiplied it times both. Then they could do that little short FOIL here. Here they had to FOIL the whole thing out. And here they did the short FOIL. Then they simplified I squared. And they finally got it down to this and finally down to -1/2 I. Okay, so on the next page, they went ahead and they took the first one and they wrote it in polar form. And I'm going to write in my book, which I shouldn't do, but I'm going to write right here. And they simplified this to 2 CIS 60, right? And then they took the other one and they simplified it to 4 CIS 150. Okay? So we could do a whole bunch of work on that, but let's take a look down here. Here's the formula for simplifying this problem right here. So let's take this problem in this form right here that they finally simplified it down to. We had 2 CIS 60 divided by 4 CIS 150. And the book says, okay, in order to do this, we're going to divide these two numbers. Instead of multiplying them like we did before, we're going to divide them. So that would be 1/2, right? And this would be CIS. And then they went ahead and they say, instead of adding these two numbers, subtract them. So it's 60 take away 150, which would be a negative 90, like that. So that's what they did there. They subtracted the two. Okay. And then negative 90, what is a negative 90? Well, a negative 90 from 360 would be 270. So you could probably, use 270 or a negative 90. We could expand this out as 1/2 cosine 270 plus I sine. Of course, this is 1/2 is times the whole thing. Sine 270. Like that. What is the cosine of 270? I don't have my chart handy, of course. Here it is. Cosine of 270 is 0. And sine of I-70, I think is let's see, -1, huh? I wasn't sure if it was -1 or +1. So this is I times -1 plus. So 1/2 times this, well, 0 is just 0. We don't need that. So this would be 1/2 times -1. This would be a -1/2 I, if you wanted to simplify it down to -1/2 I. And look at the page right here. Isn't that what they got? I guess you can't see that page, but look at it right here, -1/2 I. See? So we could have put it in this form, or we can even use the -90. If you use -90 up here, I guess it's not the end of the world. Put the degrees, and put a -90 here. But you can also put 270. So a very interesting little problem here. So let's try a couple of these things, see what we can do. Let's try another one of these. Okay, suppose we had 10 CIS -60 divided by 5 CIS 150. Okay, so 5 into 10 is 2. CIS, this would be, I'm going to jot it down here, -60 minus 150 would be a -210. So expanding this out, this would be 2 times the quantity cosine -210 plus I sine -210. Now, what is the cosine of -210? The cosine of -210? Well, that's kind of interesting. Let's add 360 to that. Did they go ahead and add 360? I don't know. They just put -210. See, cosine would be radical 3 over 2. And for the sine, they used a positive 1/2. So I guess we would have to add 360 to that. So 360 and minus 210. Let's use 150. I think it's easier. Let's see if we get the same answer they came up with. Let's see what happens. Cosine of 150. Cosine is negative radical 3 over 2. Yeah, that's what they came up with, see? 2 times that. They didn't put this in the book, but I think this is kind of important. And the sine of 150, 1/2. So this is I 1/2 I, okay, which is right like that. Well, let's distribute this out. Let's move the 2. This 2 is going to cancel out when I distribute it. This will be negative radical 3 plus this 2 is going to cancel out this 2, so it'll be just I. So now this would be a polar form, or you could leave it like right here. There's polar, and then this is your rectangular form. So we've expressed the exalt in rectangular form, but we could also write it in polar. So that would be the polar, right here, rectangular right here. I would change this by adding negative 210 to the 360. I think that's kind of important. Let's try one more that we're going to do, and we're going to do this with using a calculator. Okay, here we have 9.3 CIS, 125.2 degrees times 2.7 CIS, 49.8. Let's find it in rectangular, in polar, and then into rectangular. Okay, so in polar, we're going to multiply 9.3 times 2.7. If I can find a calculator here. If it's a mess. Here we got a calculator. Okay, let's clear this whole thing out. So I got 9.3 times 2.7. So I got 25.11. Okay, that was easy enough, huh? And now I'm going to add these together. So this is CIS 125 plus 49.8. Was it 125 even? Oh, 125.2. 0.2 plus 49.8. 175 degrees. Okay. So let's expand that out now. And right now, that would be polar form. You could leave it like that. That's your polar form. But let's expand it out. Cosine 175 plus I sine 175. Okay, so all we're going to do is look up the cosine. Just hit our cosine key, 175. Because, make sure your calculator, let's go back here. Let's make sure our calculator is set in degrees, okay? Clear, okay. Because very important, cosine 175. Yeah, because you don't know how many times I've seen mistakes like that, including my own. This came out to be a negative point. I'm just going to carry it out 4 places. Usually that's what we used to do back in the old days. And let's look up the sine of 175. Let's go back up here, just change this to sine equals 0.0871, 0.0872 I times 25.11. Okay, so did they go ahead? They went ahead and just distributed that. Let's see. I probably should have done it right away. 0.9962 times 2511. And I come up with 25 negative 25.0. I'm just going to go out 2 places. Okay. Well, we'll go out the other ones. 4, 5. That's what they did. Plus, you can see there's a little difference because I didn't go out as many places as they did. 25.11 times 0.0872. So that's how they got their answers here. This would be 2.18. And And then this is going to round up the, oh, I guess it's 9596. There we go. So approximately that would, and don't forget the I. Okay, so a little bit off. I'm off, let's see, this is tens, hundreds, thousands, 10,000s. I'm off 10,000, you know. So that's not going to be a huge difference. Okay, so that's the whole idea behind it. On the next example, they're using radians. You might want to convert those radians to degrees. It might be easier to work with. Unless you want to work with radians. But to change a radian, remember to degrees, you're just going to multiply it by 180 over pi. So 3/4 would be 3 times 180 divided by, the pi's are cancel, divided by 4. So that's 135 degrees. So, you know, if it's easier to work, it usually is easier to work in degrees than radians. You can convert those. What about pi over 5? So pi over 5 times 180 over pi. No. Yes. Pi's cancel. So 180 divided by pi. 180 divided by 5, excuse me, is 36 degrees. So, you know, if you don't want to work with the radians and you want to convert them over to degrees, then this would be an easier way to do it. This would be 10.42 CIS 135 divided by 5.21 CIS 36 degrees. And it might be easier to use your calculator that way. And then you can see that this is going to be 2 CIS, and then it'd be 135 take away 36, 99 degrees. And that way you can work just in the degrees and don't have to get involved with all the fractions on that second example. I'm not going to go through the whole thing. Remember, when you divide, you divide the whole numbers and you subtract the angles. So kind of two interesting theorems. These are the last two theorems you're going to have. We're not going to do 8.4. I know you're disappointed, but you really don't want to find the cube roots of numbers and the fifth roots of numbers using polar coordinates. It's a long, tedious, messy type of computation. If you think this is bad, that's even worse. So, you know, if you go through the examples in the book, it's pretty straightforward. Just avoid, you know, all this junk right here and all this up here, you know. This is just showing how they derived it. What you're concerned with is just this formula right here. This is what you want. Multiply your numbers and add your angles. Same thing over here. Avoid all that junk and just get down to here. So what you're going to do is divide the numbers and subtract the angles. Then you put it in expanded form, and then you can convert over to rectangular form. Okay, so I hope you enjoyed this, and don't work too hard, okay?